Hello, my name is Caroline and I make easy to digest technology videos. Today's video is about the high-level structure of OpenSearch and the primary way to interact with it, which is via its REST APIs. For more information on how to install and run OpenSearch locally or index and search for your first documents, please check out my previous videos. But in today's video, I'm going to walk through how OpenSearch works high level in kind of three main steps and show demos of each step with a REST API call in DevTools. So OpenSearch exposes everything through RESTful endpoints. So you can just call get, put, post, delete on different endpoints to achieve what you need. So first, you're going to send your data as JSON via REST APIs to OpenSearch. There's also a variety of different connectors that you can use to send data, especially if you're using the AWS service version. So for example, with the team I'm on, we push a lot of data to OpenSearch using Databricks, which is very efficient. It leverages a distributed Spark framework, but we also use Java or Python microservices for document content and extraction and indexing as well. So I'm just going to quickly show an example of pushing some data to OpenSearch. This builds on the movies index we created in the previous video. So we can see we have this movies index here with two documents. If I do a search, I can see I have Interstellar and Lord of the Rings saved as science fiction and fantasy movies, respectively. So if I want to add an additional movie here, I can just call this doc endpoint, specify that 3 is the unique identifier we want for this movie or this file, and then send all of the data that we care about as JSON. So just run this command. And if I do another search across everything that is in the movie's index, I can see the 5th element being returned. So by default, all of the data that you send to OpenSearch is indexed. You don't have to worry about building the backend data structures. OpenSearch does all of that automatically, but you can control how things are made searchable by specifying your index mapping, what data types or searching behaviors that you want to be supported. So for example, if you want to aggregate document counts on unique values of a field, you want to make sure that it has a keyword data type. You can also apply different analyzers to text to control how the text is tokenized and therefore searchable. Let me know in the comments if anyone wants me to do a deep dive on analyzers or tokenization. I can kind of dive into that in a separate video. But I would highly recommend controlling how things are indexed by specifying your index mapping. So if we check the index mapping of what we currently have, and we didn't specify the mapping of this before we pushed documents to it. So this is sort of what was created by default. So we can see for most of the text fields, it just has by default both a text and keyword data type. They ignore any keyword above 256 characters. And they also have the long data type for year, which is a very large integer. So we definitely don't need it to be long type. And we know that there's inefficiencies here because we would never need to pivot on plot summary. There should only be one movie with that plot summary. So having it as a keyword doesn't really make sense. So instead, what you would typically do is specify the index mapping of this index before you push documents into it. And here's an example of what that could look like, right? So here, if we wanted to specify something had two different data types, we could do it with this syntax. So here, director is both a text and a keyword field. Genre, we have made only keyword field, which makes sense. We probably don't need to do any text analysis on this. We just want to know or return all of the movies that are in a specific genre. And then here we've made year an integer type. So this is just a quick example of how we could control the index mapping. And then the last step is getting data out of OpenSearch, right? So you can use, there are a couple ways to do this. You can use OpenSearch dashboards, and that's kind of the equivalent of Kibana for visualization or for monitoring a production system. Or you can create a custom interface, an API which interacts with the OpenSearch APIs. And OpenSearch supports field matching, it supports Boolean expressions, filtering, sorting, etc. So to go into some examples here, so now that we have these 3 movies in here, let's say, for example, we wanted to just see all of the science fiction movies. So we could do, oops, goodness, we could do a filter here, a terms filter, where we only want to see the things that have the genre science fiction. Okay, so we've done a Boolean filter for the value science fiction, and we can see that Interstellar and Fifth Element are returned and Lord of the Rings is not. Filtering will also improve your search performance because it's kind of a Boolean filter that can get applied before you do any text or relevance ranking after that. So it is a way to make sure that you're running as efficiently as possible. Just a side note there. Another example of a search that we can do is maybe we can do some sorting. So let's say we'll just do a match all, and we want to sort what gets returned by, let's say, the year, right? So we're going to search for everything in the index, but return it in descending order by year. Okay, so now we can see the first one is Interstellar, 2014, then Lord of the Rings, 2001, and then The Fifth Element, 1997. So those are just some examples. You can see how this might start to translate what a user would be interested in querying, how that could get translated to an OpenSearch API call. So I hope this was helpful, and I will see you in the next video. Thanks.